Okay, welcome everyone. My name is Heike Ritter and I will be your host for this webinar. Thanks for joining and thanks for being part of our community. A few reminders before we start. All of these webinars will be recorded and shared publicly afterwards on our community at aka.ms/security-webinars. During the webinar, please feel free to ask questions at any time by typing them in the live event Q&A window by clicking on Ask a Question. Questions you post might be made publicly available, and if you prefer, you can post your question anonymously by checking the box right below where you enter it. As you can imagine, we often get many questions here, so we are doing our best to respond to all of them in real time. If the answer was not provided, if you have additional questions afterwards, or if you are actually listening to this after the fact as a recording, please don't hesitate to ask your question on the Microsoft 365 Defender forum at aka.ms/m365dtc. Please also join that community. That's always the best way to ensure you don't miss any future webinars or major announcements. And in our community, you can speak directly to the engineering teams that are building our product. So please join. We love to hear your feedback as well on how we can improve these webinars. Please do so at the end at aka.ms/security-webinar feedback. And this is important so we can deliver the content you're looking for. So today's episode of our monthly threat insights will focus on the malware Jupiter, aka Solar Marker. And I'm handing over to you, Elif. Please take it.
Thanks, Heike. Today's webinar is going to be covering Jupiter, otherwise known as Solar Marker, and a few other names. And we're going to be covering the content that we have released internally for our customers through Threat Analytics, through this monthly platform, through Monthly Threat Insights. So Jupiter also is known through the community as Solar Marker, Yellow Cockatoo, Polazert, or sometimes referred to by its individual components as Mars Deimos or just Deimos. So some background on the naming. I believe that the initial naming was Jupiter InfoStealer from MorphoSec, and then that evolved and different organizations had different names that were adopted based on different qualities of the malware. Solar Marker is currently the most popularly used term to refer to this malware, in part due to a previous .dat file that was used to identify clients that were infected with the malware. And so they would have an actual file called solarmarker.dat located on their computer. And the Jupiter, Mars, Uranus, and Deimos references are also part of the fun astrological or astronomical references that are kind of littered throughout this malware, and part of why it has so many different names. For the purposes of this talk, we're going to refer to it as either Jupiter or Solar Marker, as those are the most commonly used names, just so that we can make sure that anyone looking for content related to this malware can find it all. So the Jupiter InfoStealer is known for being particularly lightweight and populous. So it is incredibly popular to find on enterprise or consumer endpoints, in part because of its method of delivery. So it's both an information stealer, a keylogger, a backdoor, and can facilitate additional malware delivery, which we have seen and we will discuss here. So its primary method of delivery, which is active as of yesterday when we investigated, is search engine optimization manipulation. This is not actually done through the manipulation of AdWords or other keywords to bring their search results up, but instead through the stuffing of documents with keywords that users would regularly search for into PDF documents that are available through any search engine. And so these PDF documents are benign initially when they appear in search, and the initial page will appear as is what you were searching for. So whether that's you're searching for a template, for a contract, or you're searching for some kind of instructions to sign up for some service, you'll receive the first page that encourages you to download a document which contains the file you're looking for, and then there'll be about 13 or more pages afterwards that contain stuffed keywords to help bring that up. And so when you actually search for, and it's still live, many of the keywords that we'll talk about in this presentation, you'll be able to find Solar Marker or Jupyter instances throughout search engines. So another aspect of Jupyter and its delivery method here is that it abuses particularly cloud hosting providers and content delivery networks in order to host their initial PDFs, which are used to get the user to download the documents. Currently, they have at least hundreds of thousands of PDFs that were present at the highest mark that we saw. It is difficult to ascertain the true infrastructure scale due to the volume of different cloud providers that they utilize in order to host their documents. However, as of yesterday and as of this past month, they are still delivering PDF documents to Infect enterprise users very regularly to great success. They're particularly resistant to takedown in part due to this method of delivery because it's so decentralized and it's very difficult for defenders and blue teams to identify exactly how the file came in, which we'll cover a little bit about how you can kind of work around that to still detect this malware. And it is currently one of the more popular enterprise endpoint malwares that we are currently seeing. The saving grace, of course, at this very moment is that it is not currently known to lead to ransomware, but it is known to lead to credential theft, backdoor, and other capabilities. So as we discussed in the last slide, the operators in this instance rely on cloud hosting providers to not take them down so that they can host PDF documents, which will contain download links. Those download links, once they get the user to interact with them, will generate advertising revenue before the user downloads the file. What this looks like is that when the user reaches the page, let's say the user is looking for a contract template, they will see an option to download a document or a PDF. No matter which button they select, they will be then redirected through a series of anomalous TLDs or top-level domains, generally .tk, but we've also seen .ml, .site, and .gq. They'll be redirected through about 5 to 8 of these sites, which the user will see as a kind of loading screen. And then the final page they'll land on will imitate Google Drive, but it will also be one of these kind of unusual TLD sites. And then once the user clicks download on that final page, they will receive either the malicious payload or they will receive a benign document or PDF that is not the document that they search for. The reasoning we assume for this chance of you receiving a benign executable instead of a malicious executable is likely to reduce the chance that this infrastructure is identified as malicious. That being said, it is highly likely as a result that the amount of people navigating to these PDF documents is much higher than the actual executable hits that are seen or observed on endpoint, due to the fact that the attackers have added in a small buffer here of benign downloads. During the redirection phase that happens, the attacker will also frequently redirect to ad affiliates. This does not happen in every instance, but in many of the modern instances of this malware, the user will observe the redirection to the .tk, .ml, or .gq sites. But in the back end, in the network capture, there will be potentially up to 100 or more ad affiliate sites also directed to in order to generate revenue, regardless of whether or not the user in question downloads the documents. On the topics of the keywords here that are used to surface these documents, they are very wide in terms of what is available. The assumption here is that the keywords are generated from search trends in general because, as we covered here, it could be horoscopes, dating advice, or technical manuals, contracts, instructions, menus, pretty much anything that is popular to search for in a search engine has a chance of, if you go enough pages down, to surface a Solar Marker or Jupyter instance. So to recap over exactly how this delivery works, the user in every instance that we have observed is going to try and do a search. We've also observed, especially recently, that one of two things will happen. Either the user will directly click from the search results onto the PDF that Solar Marker is hosted within, or they will go to another site like how to start your own LLC or something like that, and there will actually be a malicious advertising pop-up or embed on that site, which will then lead them to the PDF, which will be hosted on the cloud providers that is used. So again, once the page hosting the PDF will ask the user to download a PDF or doc, and we'll have an image of that shortly. They'll be redirected to a series of loading pages, regardless of what happens. And then they'll end up at a final spoofed Google Docs page, asking them to download either a fake file containing completely unrelated text to your search, or a malware payload with the extension and same name as what you searched for. So for example, if you searched for instructions on car repair, instead of receiving instructions on carrepair.pdf, you'd receive instructions on carrepair.exe. And the expectation there is that the victim will open it. And then in the background during this loading phase, the attacker may contact ad affiliate sites. Again, this is another method of revenue generation for the attackers, one that is highly more likely for them to have success with than traditional mining and other methods of revenue generation, because it is not necessarily seen as instantly illegitimate or instantly malicious. So if as of this past year, we've seen them use Google Sites, Amazon AWS, and strikingly CDN, but they have used other services as well, including web.app and potentially other services that they will use in the future for the same purpose. The only real limiter here is they need a cloud provider that will allow them to host a large series of PDFs at once. And they need a cloud provider that will probably be resistant to taking them down. PDF or doc files that the user navigates to will also contain at least up to 190 links within the file to other PDF files. This kind of infers to us that each individual S3 bucket or each individual hosting account that the attacker either compromises or creates may have at least 180 instances of the malware that the user could navigate to, which translates for our purposes to at least 190 searches or types of searches that have a chance to bring the user to that particular bucket or account. And again, we've covered about how the delivery kind of works and the multiple redirects, which also function to hopefully try and trip up sandboxes and make it the user have a little more difficulty understanding what's occurring. So this is an example of a kind of astrological version of the search result. I didn't actually check this one yesterday to see if it's still up, but I think it may be, of an Amazon S3 bucket that is servicing Jupyter malware with the search result, Aries ma'am stopped texting me. And as you can see here, it's not a sponsored post, it's not an ad. There are just so many keywords, and they're particularly focusing on these kind of keywords that will bring it up to the fourth result without actually paying for ads in it as well, just from keyword stuffing. And so if the user was to go here and there was a chance that they clicked on this PDF, they would then be navigated to the site. So the sites in question look somewhat like this. This top example here is a Google Sites version, which is a bit older. This bottom one here is an Amazon S3 or strikingly CDN version, which was the most recent one that we've observed. And so here you'll see, and it's a bit small, so apologies, the same format of download PDF or download doc. Again, these will go to the same location. The only change between these two is it will alter if you do get the fake file as opposed to the payload, it will assure that it matches the extension of these. If you get the payload, though, it will be a .exe and it won't matter. And then up here at the top, which is very small, you can see the links to the additional pages and additional search results. And again, many of these sites are still up. The amount of search results are very common. So if you go and kind of search around on Google for common searches that are maybe not too common, chances of finding one of these are still pretty good. And again, this apologies for the not super high quality screenshot here, but this is an example of the keyword stuffing on the Aries texting one, where here is just one of about like 13 pages of just keywords that presumably will help it rise in the search results. And then finally, here's an example of one of the .tk sites, which is marked as a final download site, which will mimic Google Drive and attempt to get you to download the PDF doc exe file in order to install Jupyter/Solar Marker. So once all of that kind of has been resolved and the user now has this exe on their computer, a series of actions will start to occur. Almost all, or rather all of Jupyter's actions at this point are automated. Each individual download may behave slightly differently due to different versions over time. So the one that we'll be discussing here today was popular in June and May, and almost all of the behavior is still relevant as of this week, with some changes that I'll note at the end. So Jupyter is particularly noted for it will immediately run its the same executable, and you will see the initiating process from that point on as a .temp version of the same name. And that will be a key that you can use to validate the advanced hunting queries that we have later on and confirm that it is in fact coming from something like Jupyter or Solar Marker rather than coming from some other file. From there, Jupyter will run a very large obfuscated PowerShell script, which will attempt to XOR and encode multiple times the script in order to bypass other detections that are available for encoded or obfuscated PowerShell. This is still detected fairly well in terms of it because it is a very obvious looking obfuscation that is occurring. And after it downloads its additional components and gets them executed, one thing that was particularly common in the June downloads is that the malware would directly install an ad delivery platform called YouTube Downloader. And YouTube Downloader, while that sounds like it will just download YouTube videos from YouTube, is actually a monetization component of this malware and other malware. The malware itself will download this in order to encourage the user to either subscribe to the YouTube downloader, but it will also scrape web credential and web cookie data and serve you more ads in order to both monetize and for keeping score. The ad monetization occurs before the user downloads and after the user downloads with an additional download component. So this is very similar when we look at the kill chain to if this malware had downloaded a miner. And so that is a good way to look at the way that this malware and other malware may increasingly download ad generation components in order to have a more steady stream of revenue in addition to the credential theft and keylogging that will occur. So the primary PowerShell script also, as we discussed, is obfuscated and will place the Jupyter payload into startup in order to try and establish persistent and will load the subsequent functions and assign a client ID to the host. The line between simple malware and botnet is definitely blurred in these instances where the infection is persistent and there is a method where the attacker can issue additional commands and also assign a unique identity to the host. So this is just an example. It's just a screenshot of what the encoded PowerShell would have looked like a few months ago. As of yesterday, it still looks nearly identical to this. And for all of the kind of efforts of obfuscation here, it's still fairly trivial to monitor and detect for this kind of activity. So the script itself will launch additional processes. So you will start to see the malicious activity not coming from that .temp file that we discussed earlier anymore. It will also load in the component referred to as Mars Deimos. This will sometimes be referred to by other vendors as Mars or as Deimos. The actual component's name is Deimos, and there are other good write-ups around the web on the specifics of what Deimos does. Additionally, there is another component similar to this theme called Uran or Uranus, but that has not been currently observed in enterprise clients at this time. Mars Deimos, however, will be observed in almost every instance of the Jupiter solar marker infection. It may also be observed in infections that do not have a Jupiter solar marker initiation, but may be related to the operator or the malware. So it will gather telemetry on the host in order to send those back to the attacker themselves. And will additionally scrape and collect other data, including the system information, cookies, login data, web credentials, and other cache information. Initially, a file called solarmarker.dat at this time was also generated in the app data folder in order to both house the host identifier and other information. As of recent versions, the solarmarker.dat file is less likely to be spotted. Instead, in the same location in your app data roaming folder, there will likely be a series of randomly generated characters demarcated with a dot in the middle that you'll see as this kind of host identifier instead. But you won't see the solar marker or the .dat necessarily in every new infection. The rest of the behavior will be the same though. And this is just a screenshot here of just some of the decompiled information of the Deimos component. Checking for various configurations on the host. Additionally, there is a fairly small set of IP addresses that are hard-coded to exfiltrate data to. As of this past week, most of those IP addresses are still in use for exfiltration purposes. So that does not seem to have changed either to use of an entirely new IP set or an entirely new domain set. But of course, that could change in the future. IP-based detection is not particularly resilient. But if you're going through attempting to find this kind of information, you should be able to find an instance of Jupiter solar marker just through the AHQs and the behaviors. But the indicator, if you are investigating an infection that the data was actually exfiltrated, will be a direct IP connection at this time. We have not observed them moving to DNS exfiltration. So the reason to kind of be concerned about Jupiter in general in this landscape of so many different pieces of malware is mainly that it's very resilient. So it has been known about for at least 1.5 to 2 years, but is still very sizable. It maintains a very regular new device infection range. And from an analyst perspective at Microsoft that works with email and phishing also quite frequently, this method of SEO and malvertising delivery is more effective in general than a lot of phishing attempts in terms of the chance of it getting an enterprise user to download the device. And so in the past, I know that blue teams and individual organizations may have a harder time identifying the root cause of something that comes from a web download, but attackers also are aware of that and are increasingly moving not necessarily back, but we are seeing more and more populist malware getting more and more enterprise users through either web downloads through this method, through search engine optimization, or through fake legitimate applications. There are also quite a few both commodity and more advanced malware leveraging fake applications in order to get downloads. And so Jupiter's resilient infrastructure is one of the reasons to have a concern a long time going forward. It doesn't update very often in terms of its behavior due to its success in general. So by going through the threat analytics report that we have and kind of maintaining that the ways in which it operates right now would not be effective against your organization, you should be safe for a good amount of time. The primary targets are English-speaking countries. This is more than likely because of the usage of keyword stuffing here. The vast disparity between countries does indicate to us that it is both preferring to raise search results on search engines popular in English-speaking countries, but also that they are particularly only using English keywords. We have seen in the past malware abuse keywords in other languages and target other countries. So Jupyter and SolarMarker are certainly not the only malware to abuse search engines or keywords. But in this instance, if you are in an English-speaking country and you have not assessed if a Jupyter infection is in your network, these are things that could indicate that this is something to look for. And this is just a graph from the last period through mid-June or mid-July through March of just how many new infected devices we were kind of observing on SolarMarker per day. So the mitigations that we suggest for this, especially whether or not you use Microsoft Defender or otherwise, is to search within your antivirus or EDR product and make sure that you have something called PUA or potentially unwanted application protection turned on. Due to the classification of commodity versus advanced threats, other malware vendors may classify info stealers or backdoors, or especially anything related to advertising or ad fraud, as a potentially unwanted program rather than malware. So definitely assess what your organization's stance is for that and consider turning it on in that instance, especially if the antivirus or EDR product that you're using doesn't have actual detections for this malware itself. Additionally, if you are using Microsoft Defender antivirus or an equivalent, please turn on cloud delivered protection so that you can receive real-time updates about changes in detection status for malware as we make changes internally. Tamper protection will also help prevent Defender and other services from stopping, which is a very common tactic here. You can also make custom detections with the AHQs that we will provide and have provided in our threat analytics report, as well as turn on the EDR solution in block mode so that instances of behavior-based detection through the EDR product that will detect things like those obfuscated malicious scripts will always kind of notice that it's a suspicious script and block it. Network protection is also an available feature within Microsoft Defender to assure that you have the kind of anomalous and domain detection, which will serve to help protect against those .tk dynamically generated domains that we mentioned earlier. Additionally, we have attack surface reduction rules that can help also prevent a large swath of malware. This will generally work to prevent by changing a larger feature, more similar to things like application allow listing or block listing, as well as larger changes in Office products and lateral movement that could occur through USB. So if you are assessing an ASR rule before implementation, there is an ability to assess the impact of that on your organization before implementing it. And again, ASR rules are smaller in scope, but larger in impact because they'll impact the entire organization for a larger change, like, for example, preventing Office macros from calling certain processes. We do have individual SolarMarkers and SolarMarker and Deimos detections. Again, Deimos for the instances where that component may be seen with other initiating malware. And so this is just an example of things in your environment. And again, this will be shown in the threat analytics report as well, which will actually do this kind of checking automatically for you. So if you have any of these kind of detections in your environment, a threat analytics report on the particular malware in question will alert you to the devices that are exhibiting behavior if we have resilient signatures here. We also have some generic signatures that will detect the individual behaviors, but may not say Solar Marker or Deimos on them individually. And so we generally, in all of our reports, will provide those as well. We additionally, on the EDR side, we have individual behavioral-based detections for the types of behaviors that we've covered today, including, and these will be labeled with Jupyter malware, Jupyter network activity, or Jupyter exfiltration activity. And so those will also be associated with the threat analytics report. We've also included, similar to the EDR or to the Defender side, a series of generic detections that EDR might fire when it sees this activity. These detections could be also associated with almost any other malware, with the exception of the EDR alert for activity resembling Jupyter malware. But suspicious PowerShell command line, theft of web browser information, when you're going through an investigation, whether this is on Jupyter or Solar Marker, the inclusion of this kind of generic information will both help defenders quickly identify what has happened with the malware and what it succeeded in doing, because it is behavioral based, and it will also help identify additional malware that may be using these particular instances. And so the combination of the resilient detections, the behavioral detections, and these kind of generic behavioral detections will help get a quick picture on everything that the malware has done in the environment and what you can expect to observe in other hosts in your network that are also exhibiting similar behavior. And so we're nearing the end, and just for those interested in the advanced hunting queries, I'll actually go and just demonstrate those. We publish these internally within the threat analytics report, which I'm displaying now on my screen, where all of this content will be released significantly before we release any public blogs or other data. So all of this will be here for those that have access. And we include a section on advanced hunting queries. So advanced hunting queries are generally things that you can expect to not have show up in either the EDR or Defender alerts, or show up in conjunction with them. In instances where there are a large number of generic EDR alerts, the advanced hunting queries may be queries that are very effective at highlighting malicious activity from this malware, but might have a chance of false positives. And because of that, we encourage customers to run them in their environment when they read the report in order to confirm that any of the activity is this malware, and also to either highlight other additional malware or make custom detections if, when you run this, you find that there are no false positives in your environment. So we do get that question a lot about advanced hunting, and we do recommend that any instance where you are investigating a report to run this and assess the true positive to false positive impact in your environment when considering creating a custom detection for this malware. And so both for the obfuscated PowerShell scripts, the Deimos execution and exfiltration, we have these in the advanced hunting query in the report. Often we will also publish the advanced hunting queries themselves externally. So if you go to aka.ms/Jupyter, spelled with a PY, AHQ, aka.ms/Jupyter AHQ, you'll actually come to our Microsoft 365 Defender hunting queries page, where you'll see all of the hunting queries that we had for threat analytics available here. So for example, this one here is the Deimos execution that you can search for, and we'll also include the MITRE sections that it is applicable to. So you'll be able to kind of observe, even if you don't have Defender or EDR through us, you'll be able to use this and easily convert the KQL or Kusto query language results that we have here into other query languages that you may need, because these queries are very kind of behavioral based and can be modified as necessary. So here we also have additional campaigns as well, including we have the sister botnet, which we discussed last month, Loader, Call, Lemon Duck, and more advanced hunting queries in this publicly available repository. Again, not all of our information from our threat analytics reports will be here, but especially if it is a very populous malware or we've spoken about it publicly, we will try and assure that it is here as well. Additionally, if this is your first time kind of engaging with KQL, whether you have the product or not, the query language that we utilize has a syntax guide that is fairly helpful. And if you don't know anything about what KQL is, you can go to aka.ms/KQL in order to get a bigger overview of what Kusto is and what Kusto query language is in general. And just catching back up. Generally in threat analytics reports or in public blogs that we release, we may sometimes include indicators just so that you can also do your own research in order to validate some of the information. We do not generally keep these indicators up to date in the reports, but just as of the time of this report, we will sometimes include this kind of information just so that there is a way to kind of help contextualize what we've talked about with the actual artifacts that you can look up in VirusTool or something else to see what it is. Additionally, some of these kind of artifacts are related to the malware, but won't necessarily fire the same alerts. In this example, the YouTube downloader is an example of something that is dropped by the malware for revenue generation, but will not necessarily alert as malware itself, but might alert as ad fraud, malvertising, or as grayware, which harkens back to that mitigation about turning on PUA protection. Also, we generally do try and include, for those that do require it, the MITRE techniques that are observed with a particular operator or a particular malware. And this is just a sample of the ones that are observed through this particular malware. And that's about it that we have here for Solar Marker in Jupyter today. Based on what we've talked about, there has been some minor changes to the malware, but as of yesterday, all of the advanced hunting queries should still surface new infections, as well as the content in the threat analytics report should still be current as of our current research. And so we'll continue to investigate and update our information on both this malware and other malware that we produce threat analytics report on. So definitely when we do an update on any particular report, we'll make sure to include a notes and an update section so that you can identify what parts have changed. And that's about it.
Thank you so much, Elif. So before we end the call, some reminders. Recording slides will be made available at aka.ms/security webinars. Our next scheduled monthly Threat Insights webinar is on September 15. That's always the third Wednesday of the month. And for details and registrations, you can go to aka.ms/security webinars. If we missed to answer your questions, or if you have additional questions, you can visit the Microsoft 365 Defender forum at aka.ms/m365dtc, where you can find the experts. Sometimes we get questions that our SMEs in the background might not have the answer for. So again, thank you, Elif, for today's monthly Threat Insights. Thank you to the rest of the team who helped answering the questions. And of course, thank you for being part of our community and for joining us on those webinars. We hope to see you next time. Goodbye.